So we build a great and incredible application. But wait a second, there is too much calls to one endpoint. And boom, our application goes down. And again. And again. But wait, there must be a way so we can just prevent all of this from happening. To try to make our application more resilient to all of these falls and error. The short answer is absolutely yes. This is exactly what microservices are for. In these codes, we will learn everything needed to know for you to create your first microservices application. So, let's go straight into it. Real quick, think about every business owner you know, the restaurant, the consultant, the coach, that local business trying to grow online. Most of them have a website. Most of those websites are doing nothing. They look like they were built in 2012. They don't convert. They don't represent the business, and the owner has no idea of how to fix it. That gap, that is literally why you are learning this, because businesses need people who can build things that actually work and actually look the part. Polaris is a studio that serves exactly those businesses. They build, design, and experiences for companies that are serious about their digital presence. No templates, no drag and drop, real work, built from scratch, build to convert. If you know a business owner in that situation, or if you are building something yourself, send them to the polaris.studio website. It's the kind of work that reminds you what's possible when design is taken seriously. Link below. So, alright, let's go back into the course. Now that we already know how to create great application with great feature, our next step is to understand what we need to do when our application grow bigger and bigger and have a lot of active user. In this case, our monolith backend will have a lot of requests, and with more users will become slower. That's where microservices came to help us. By splitting our application to smaller pieces, we can make our application faster and much better. Let's take an e-commerce application for example. We can split this application to smaller services like user service, order service, product service, and most services accordingly. Now those services will talk to each other under the hood and present one API that will come out of the application. And by doing all of this, the background work, our application will be stronger, faster, and will be able to grow with users exponentially. So services in microservices system need to talk to each other. There are a few ways to do so. Let's start with REST. Now you already know REST, and using REST is very similar to call to an external API with REST, and it's very much the same in microservices. You need to define the request and response, and it's very similar to what you know so far. But communication using REST is very slow. You need to send a JSON with full text, and with the HTTP protocol, it's not that good. That's why the most common way to communicate between services is gRPC. So, gRPC is very fast and reliable way of communication between services. It uses binary to communicate, and that's what makes it very reliable. And gRPC is very similar to just calling a function in our code. So, to wrap this up, we have REST and gRPC. REST is easier, but gRPC is industry standard for microservices and is most common and are used by a large company like Netflix. In microservice architecture, services need to talk to each other. The cleanest way in Spring Boot is the REST client, a modern, fluent HTTP client that replaces the old REST template. So, in this lesson, we will build two different services. Another service that calls the product service over HTTP with REST to fetch product details before compiling an order. So, let's start by creating two new services. So, we will create a new project. This one will be the product service. Just like that, we will use Maven and the YAML for the property configuration file. Click next. And now let's add a few dependency. So first of all, we add the Spring Web. So right that. We will also add Spring Data JPA. We will also add validation for our DTOs. We will also add H2 in memory database. And finally, let's add Lombok, just like that. So let's click create, and we have our first service. So now let's create our second service. New project, all service, just like that. We will use Maven, YAML, click next, and now we will add all of our dependencies. So Spring Web, just like that. Now Spring Data JPA, just like that. Now let's add H2 in the in-memory database, validation, and finally Lombok as well, just like that. It create in a new window, and now we can switch up between those two projects just like that. So let's click right here, and now let's start with our configuration. So let's configure our product service. So right here in the YAML file, we need to configure two main things. First of all is the database. We are using H2 in-memory database. This allows us not to create a Docker file and run out our database and all of that. It's work like regular SQL files, just like in memory, and when the session is over, everything is wiped out. But the good thing is that it is in memory and does not require a Docker file or all of this setup. So it's really important. So let's configure that first. So right here, we'll add the data source, so data source, just like that, and we will add the URL as well. Now the URL will look something like that, JDBC, column, H2, MEM, and now the name of our database. So for this one, it will be the product DB, just like that. And now let's configure the same database in our audio service, so just like that, SOC, main, resources, YAML, just around this. So data source URL, so JDBC H2, and this one will be the order DB, just like that. And now we will need to configure one more thing, which is the port that each service will run on. So a normal Spring Boot class runs on port 8080, so we want each service to run on its own port. So we will use this server and port, and this one will run on port 8080, just like that. But this one will run on port 8081. So server port 8081, just like that. And now we configure those two important things. So just like that. Now let's create our first product entity. So right here, new Java class, and we call it the product entity. So class, we will add it to GitHub as well. And now let's add our entity annotation to tell Spring data that this is an entity. So entity, just like that. Now let's add all of Lombok's annotation to save us a lot of boilerplate code. So just like that. Let's add the getter, the setter, the all args constructor, and also no arg constructor, and also the builder, so we can use the builder pattern just like that. Now we have this arrow because every entity needs ID field, so let's create this ID field right here, ID, and we'll use the generate value annotation. And now let's create ID, so private, and it will be string ID, just like that. And now we will need two more field because every product need at least a name and a price. So let's add those. So string name and string, not string, double for this one, and it will be the price, just like that. Now let's create real quick the product repository. So right here, new Java class interface, and it will be the product repository, just like that. And it will extend the JPA repository and the basic class. This is our entity, and the ID is for type long, just like that. Let's change right here from string to long. Let's use a number, simpler, just like that. And now let's annotate it with the repository annotation. It's like the service annotation that has springs to inject this class if we ever need it. So just like that. Now let's create the product controller with a simple get method to get a product. So right here, let's create a new Java class, product controller, just like that. And now let's add all of the annotation that tells Spring that this is a REST controller and where to find it. So REST controller, and now let's use the request mapping. So we request mapping to tell Spring to find this it the slash products endpoint, just like that, and we will use requires our constructor. So requires our constructor, this one from Lombok, to fill out our needed field. So right here, private final product repository, and we call it repository, like that. And now let's create the method to get a product by its ID. So let's use the get mapping. So get mapping, and it will be in the endpoint of slash ID, just like that. And now private response entity. This is the response entity of type product, just like that. We don't actually need a super detailed DTO for this one, and we'll call it get by ID, just like that. And we'll take the ID from right here. So let's use the param, so path variable. Let's use this annotation, and we will get a long ID, just like that. And now real simple, we will return the product. So first of all, let's keep the product right here. So product, and let's find it. So let's use the repository. So repository dot find by ID. So find by ID, and let's enter our ID, just like that, and use or else throw. We will throw this new arrow, which is product not found. So product not found, so found, just like that. Wait, and now let's throw a new and not found error. And if we don't found product, let's use or else null, just like that. We will put the value of null if it's null. If product is null, in this case we will throw a new error, new runtime exception, and we will return something like that, product not found, like that. But if we do found it, we will just return the response entity. So okay, so let's implement this method. So let's first start by finding the product. So product, we will call it product, and let's search. So repository dot find by ID, and let's put the ID right here, and we will use or else. If we don't find the product, we will use the null value right here. If the product is null, so the product equal to null, in this case we will return new response entity of type not found. So we will use the not found and build, like that. But if we do have a product right here, we will return it. So return response entity of type okay, and in the body we will add our product. So product, just like that. And now we implement our product service. Now let's go over and configure our REST. Incredible. So now let's go to the order service. It needs to call a product service over HTTP. We use a REST client for it. We inject as a Spring Boot bin and a configuration with the base URL. So let's go to the order service and create a new configuration file. So right here in the Java folder, we'll add a new file for the REST configuration. So REST client config. So just like that, we need to create this new configuration class, and ask again, just like that. We will add the configuration annotation to tell Spring that this class is for configuration, and let's create a new bin, and this bin will be for the REST client. So REST client, this one, and we'll call it product client. So product client, just like that. And now return REST client dot builder. We'll use the builder, and we will use the base URL, and let's add the URL right here, which is http:// local host, and it will be on port 8081. This is our product. This is our product URL. So just like that, and right here we will build it. So let's use the build, just like that, and this is the configuration that we need to do. So right now let's go and create our order entity. So here, new order toolbar class. Let's create it real quick. So we'll use the entity, the getter, setter, know our constructor, and all our constructor, and also the builder panel. So builder, just like that. Now let's add the ID. So the ID will be the product. The ID will be, so now let's add the ID, the generate value annotation as well, and it will be of type long. So add it long ID. And now we need the product ID, the quantity that we want to order, and the total price. So just like that, we'll add a new field, so private, it will be long, and it will call product ID, just like that. And we need a few more fields, so private quantity, so it will be also long quantity, so quantity like that. And also we need the total price, so it will be a double, and it will be total price, just like that. And now let's create our order service for our controller. So right here, let's create it, new class order service, just like that. We will use the service annotation, and also the require arg constructor. So require arg constructor, and we need to also add our repository. We forget to add those, so right here, new Java class, it will be an interface, it will be the order repository, just like that. It will extend JPA repository, it will use the order, and the type of the ID is long. So that, let's add the repository. So just like that, let's go now to the order service, and we need two main fields. So the first one will be the order repository, so order repository, just like that, order repository. And the second one will be our REST client to call to the product service. So right here, REST client, Spring will inject it, and let's create our method. So it will be public method that return types will be order. So it will call place order. So let's implement that. We need two main arguments right here, and it will be the product ID and the quantity. So long product ID, and also integer long of the quantity. So long quantity, just like that. And now let's implement the method. So we need to first problem that we don't know. This order service does not know how a product look like. So we need to implement our DTO. So let's do it real quick. New Java class, we will use record for it, and it will be the product DTO. So just like that, we can call it also the product response. It will be more appropriate. So response, just like that. We'll create this new record with all of its fields. So first field is the long ID. We also have the name, so string name, and we also have a double of price, so double per, just like that. And let's go over to the other service, and let's call it so product response. We expect to get a product response, so product, and now product client. On our REST client, let's use our REST client, and we will get the product, so we'll use the get dot URI, and we will inside the localhost 8081 we'll go to the slash product slash, just like that, ID, and we will put ID right here, so product ID. And now let's retrieve from the body, so retrieve body from the response, and we'll use the product response class, so it should look something like that. Now let's organize it more like that, and now it's look more professional. I like it. Now we need to create our order, so right here, order, we'll call it of course order equal, and we will build our order using the builder panel. So order dot builder. Now let's just remove this. So first of all, we need the product ID. So product ID, and we have the product ID right here. Next, we need the quantity, right, just like that, and we will have the quantity from right here, so quantity. And next we need the total price. Now for the total price, we retrieve the product because we don't have the product a price in the ID or something like that. So for that we need the product. So the final price, the total price will be the product price. So product dot price times the quantity. So just like that, and we will build it and just like that. So now we will return order repository. So order repository, let's save the order, just like that. And we will create our, first. Now let's go to create our controller. So just around here, new Java class, we will call it order controller, just like that. Let's add all of the annotations. So first of all, the REST controller, request mapping, and we will find it slash orders, and let's add the requires args constructor. So this is the one, and let's add our product service right here. So final order service, we will use order service, and let's create our create method. So create order. So it will be a post, and we will use the place order method for it. So right here, let's create it. We will use the post mapping, just like that, and let's do this. So public response entity. So entity, and it will return something that looks like order. We will call it create order, just like that. So now we need to add our ID and quantity. We need to get them as a parameters. So for that, we need to use the request body. So we get those in the body, and we need to create a DTO for it. So real quick, right here, new Java class or the request. It will be our DTO. We will use record for it, and we will need two things. First of all, it's long product ID, and the second one will be a long quantity. So quantity like that. And now let's add our validation. First of all, it cannot be null, not null. Just a second, and let's add the positive. So this is mean that the quantity must be a positive number, and it cannot be a negative number like or 0, like 0 or -1, 2, 3, and so on and so forth. So let's use this order service DTO right here. So DTO, we'll call it request, just like that. Now we need to return two stuff. So first of all, let's return new response entity. So return new response entity dot okay. And right here, let's use the order service real quick. Order service dot placeholder, and we need two parameters: the product ID, so request product ID, and also the quantity, so request quantity, just like that. And bam. Now this is how we use microservices. So we use the product service for our product and our order service to create an order, and we communicate between those two services by using REST. It's quite amazing, and we can build large services in this way. But in the next one, I'll show you a much faster and much reliable way that most companies are using today for their services. So let's go. So far we have used REST in our inner service communication, but REST is kind of slow because every time services need to talk to each other, they are sending a full JSON text to each other, which is much slower than the new method and the most usable method around big company with microservices, which is gRPC. gRPC is much faster method for inner service communication. It's asynchronous communication, but super fast for internal service communication. So let's start by adding the dependency to both of our project. So in every one of those pom.xml file, we will need to add a few dependency to enable and to start gRPC. So in the product service, let's add those. So right here in the pom.xml file, we will need to add a few dependency, but before we will add those dependency, we will need to create right around here between the dependencies and plugins, we will add the dependency management. So right here, dependency management. So dependency. So dependencies. Just like that, and it will come from the group ID of org.spring-framework. So spring-framework.grpc. Just like that. Now we need to add a few more properties. Version will be 1.0.0 for now. The type will be POM, so type, we will add type of POM. We will add the scope for this dependency management, and the scope will be for imports, and that's all. By adding the dependency management, tags, we allow Spring Boot to manage our gRPC dependencies. So right now we will need to add a few dependency for gRPC. So right here, let's add a few dependencies. So dependency, and this one will be for gRPC stub. So gRPC tab. This one generate the server-based classes and clients with the stub type. So it will came from io.gRPC, just like that. And let's add a few more dependency that came from the same group. So let's add. Now let's change the name. So the next one will be gRPC. So let's add just the optional tag to here. So optional if we do want to use it or not, so it will be true. So we will not need must use it. Now let's add a plugin, a new plugin. So right here in the plugins, we will add a new plugin. Right here, plugin, and this one will have the group ID of io.github.co, just like that, and it will have the artifact ID of protobuf maven plugin. So protobuf dash maven dash plugin, just like that, and we will have the extensions. So extensions will be set to true. Yes, just like that. Now let's load up a maven right here. Give it a second. Nice, just like this. Now, if you didn't understand fully all of those dependency, I will go shortly over them. So first of all, let's start with the dependency management. This will manage our gRPC dependencies, all of our dependencies. We'll make the type for the POM because we use pom.xml file. We will add the imports for the scope, so we could import them. And in more short, like Spring Boot manage its own dependency and starters like Spring Data JPA, as you can see right here. For all of the Spring framework.boot dependency, we didn't need to specify version. So this is what we did here. We specified the version right here, and now we didn't need to specify the version in those new dependencies, and we will manage all of the versions and all of those stuff right from here. And we will also add the gRPC dependency. Now you don't necessarily must understand all of the dependencies and all of this stuff. It doesn't fully needed, but it's quite important to know that they are. Now you don't must understand it, you could just import them and forget about it, but it's pretty useful to know them. Now we need to add two less dependencies for gRPC. The first one will be the gRPC star, and another one will be for the generated base classes. So right here, let's add new dependency. This one will be pretty short. It will be Spring gRPC dash Spring Boot starter. So we have right here this one, Spring Boot starter, and we'll learn from here. And we can specify the version, but we don't because we have the dependency management right here. So after a few trial and error with some of the dependencies and plugin, we need to update a few plugins. First of all, we need to remove the GitHub plugin that we have right here, and we will replace it with those plugins, right? So I will just go very shortly on what this plugin does. This is the plugin that helps us with protobuf to create those files, right? It's super important and very basic stuff. You can just copy paste it. You don't necessarily need to understand it. All that you need to know that this is the proper package for Maven plugin to create the generated gRPC packages. All of it you can just copy it just as that, and we need to also add another dependencies. So now this one is for Java annotation. So right here, this is the dependency JavaX annotation, just for a little problems that you have right here. You can just copy paste it. You don't necessarily need to understand all of that because it's just like extra stuff that frankly you can deal without. So I just like with Maven right here. Now let's go into the actual code. Let's create our proto file. So proto file right here. So SRC main right here. We need to create a new file in the, and we will put this in the proto package. So proto slash product.proto, just like that. And now let's really fast, let's create this proto file, and I will explain you exactly what each line does. So first of all, we start with the syntax. So syntax, which will be proto3 syntax, just like that. This just tells that the syntax for this file will be for the latest proto3 syntax, just like that. Now let's add two options. So option Java multiple files, that it will create multiple files. Let's just true. It will generate product requests, response as new Java classes and not just like in one file. And option Java outer classes, just like the description, holders stay separate, message classes stay easily to import. So just like that. And now let's give it the name of product purpose. So product proto, super fast. And now let's define our services. So service, and we'll call it product service. So product service. This is the service that we need to define the request. So just like that, let's RPC, and we will define the method that called get product. So product, just like that, and we will have the product request, and we will returns the product response. So product response, just like that. We just define what we are given. Will give the product request, and it will return the product response. Now let's define the product request and product response. So message, this tells how it looks like. So it would look like we have a ID. We need only the ID in the request. So we have integer 64. It's a long number. It's a whole number with 64 bytes, which is a really long number. ID equal to 1. I will explain why we need to do this equal to 1 stuff. But first of all, let's create the message for the product response. Super fast, just like that. We'll have the int64 for the ID because it will return the ID equal to 1. It will also have the string of the name equal to 2. And we have also the double for the price, and it will be equal to 3. Just like that. So we define it to equal to 1, equal to 2, equal to 3 because gRPC uses bytes, and we don't want each time to define those all names because it takes a lot of bytes and it will be slower. So we defined it to a number, which is much faster to transfer, and this is what actually makes gRPC really fast. Now we need to install. So right here, open this panel. Under lifecycle, we need to clean installs to generate those files. So hit clean and it will install. Build success. Amazing. Nice. Now we have all of our generated package. Now if you cannot see them right here, we can run it from the terminal. Right from here, it's /mv/nw, and it will be clean package, and it will install everything and create and will generate our classes super fast. Just wait for it. And we have the build success, and we have the target folder right here target, and then we have all of the generated classes for proto, like you see, proto C, all of those stuff. Now let's actually use them in our Java code. So right here we'll create a new, in the Java folder we will create a new product gRPC service. So new Java class, and we'll call it product gRPC service, just like that, and click enter. Now we'll add two annotation that you already know. So first of all will be the service, and second one will be the requires our constructor. Now we need to extend the generated class by proto. So let's just do it really quick. It will be like we will extend the base classes. So we'll use extend product service gRPC, so product service gRPC, and we will add product service implement base, so product service impl base, just like that. So now we need to extend a base class, the base class that gRPC creates. So extend product service this gRPC, and it will be product service implement, so implement base, just like this one. And we will need to define one field, so it will be private final product repository. We'll call it a product repository real fast. Now we will need to override one method, which is the get product. So override, and this is a public void get product, so get product method, and it will get the product request and will return, so product request, we need to define it real short. It's just the ID actually, but we will need to define that real quick. So request, and it will return stream observer, so stream observer of the product response. So product response, we will create those really shortly, and it will be observer. We'll call it observer, just like that. Now let's create the product request details right here, super fast. New Java class product request, it will be a record, and very short, it will be not blank, not null, and it will be like long ID. just this one super quick. And now product response. Let's create the DTO super fast. New Java class product response, a record as well. It will just be, the response will be the long ID, the string of name, and the double of the price. So just that, and we'll have the response and request. Nice. Now we'll really override this method. So we will first of all find by this, so repo product repository, find by ID, so find by D, and this is where the fun begins. So request dot ID, so right here, and now if present or else, now let's add this method if present or else, and this method takes two arguments. First of all, if we have, if it's present, and the next one is if else. Now this method takes two functions. So the first one, it will be on success when the response will come back, and the next one will be on error when we have missing product. So let's just add those real quick. When you have the product, so we will go to this method and we will add the on error. So we don't have any arguments, so we'll go to the other function. So we will go to observer.onError. So this will be the method. We will just implement it in a bit, but let's focus on when we have the product. So when we have the product, we will go to observer.onNext, and now let's implement it real quick. We will use the response, product response, and we will use the builder. So builder, and now let's just build it real quick. First of all, let's start with the ID, and we'll use the product get ID, and now in name we will use the product dot get name, and for the price we will use the product dot get price. So product dot get price, and finally we will build it just like so, and we will close this parenthesis, and we'll call the observer dot uncomplete. Now let's implement this, and right here on error we need to implement this. So first of all, we will the status, let's define the status. So status io.jsp will be not found, so not found, just like that. Now with description of product not found, so product not found will give the basic description of product not found, so found, and we will add the request, so request.id, and finally as runtime exception, and we will define it as a runtime exception, just like that. And there you have it, and this is our product gRPC service. So next we will need to configure the product gRPC port. So let's go to our application YAML real quick. We will add Spring gRPC, and we will add the port real quick. So under the port we will add right here under Spring application, right here above that Spring gRPC, and we'll have quickly server, and we will use the port of 1990, and just like that, those are the configuration that we need to add in the YAML file. And if we'll run the application, we will have our REST application on 8080, 8081, and our gRPC on 9090. So now let's go to the other service and add all of the configurations and all of the things that we are needed. So right here, so in the other service, let's go project pom.xml file, and now we will add all of the needed dependencies. So right from here, let's go to our POM, and real quick, let's add all of our dependency. Let's start with the dependency management. Go right here, and let's add us between those two. Now let's add the plugins. So from plugins all the way up to here, we will copy it right here. Plugins, let's add this new plugin right here, and we need to add all of the dependencies. So right from here all the way up to here, just add those dependencies, nice and easy. And let's also add the Java syntax annotation right from here. Let's add this right above them right here. And now sync it up with Maven real quick. Amazing, everything working, nice. Now let's go to the application YAML real quick. Let's do all of those stuff real fast. So application resources YAML right here, and let's add the gRPC settings. So right under Spring gRPC column client, so client, because this is the client, and let's add the channels that gRPC will listen us, so channels just like that, and it will be the product service, so product service will be the values of it will be, and the address, so address of the product service will be at local host, and the port we have just defined 8090. Great. Now let's create our gRPC client configuration class. So right here under Java package, new Java class, and we'll call it gRPC client config. Config, just like that. We'll add the configuration annotation, so configuration, this one, and we'll add a new bin, so right here bin, and it will be the type of product service gRPC, so product service gRPC dot product, wait for it, service blocking stop, so blocking stub, this one, and it will be called product, let's make it like for product stop just, and it will take one arguments of gRPC channel factory, so gRPC channels factory, and we will call it channels, just like channels, I think will be enough. Nice. Now real quick, return product service, so product service gRPC, this one, so this is a long one, so dot new blocking stub, and right now let's call the channels dot create channel, and it will be the product, so product service channel. And that's all for our configuration. The channels, we will create a new gRPC channel, and this is the channel that we have defined in our YAML file. So real fast now to solve those problems, because we don't want to take long. In a normal project, you have this big project that call like the company like AI generated images, you may call it a project, and then you will have all of the product service folder, and then other service and all of those folders, and then you will have one folder that you could share like product contract, and then you will have the contract for all of the stuff, like a one for the gRPC and all of that. But right now, as we just want to show a demonstration, we will just copy the proto file, so it will be generated right here as well. This is not the solution that we will use in our project, but for now it will be sufficient enough. We'll have right here the proto with the content. Now let's just generate the classes. Now let's remove it so it won't interfere with our build right here. We will build that real quick. So build, and now we have build success. Now let's port it. So after we run our proto file right here, everything is working. Now this error is IntelliJ error, so we will not be bothered by it right now. So because IntelliJ does not understand from where we get it, the code is exist, it's working, but now let's focus in creating the code itself. So let's go and create our gRPC order service. So new class order service gRPC, just like that. Let's get the class real quick with the service annotation, and let's add the require constructor super fast. Let's just go fast with that. Let's add the private final product service gRPC, so product service gRPC dot product service blocking stop, so product service blocking stub, and we'll call it product stop, so product stop, shorter name, and let's just use the order repository, so private final order repository, and we'll use order repository. And now let's create our placeholder method, so public will return order, and it will call it place order, and we will take two parameters. The first one will be not the order as it suggested, it will be the long product ID and the quantity, so long product ID and long quant. Nice. Now we will need the product response, so product response, this comes from the generated files, and IntelliJ does not recognize them, but let's not worry about it. It's there and it's working. It will be equal to product stub dot, and we'll use the get product method, so get product method, so product request, let's create builder, so product request dot builder, so builder, and we will have the and product ID, and we will also build it. So let's just like build it, bang, and that's it for our product response. Now we will return order repository dot save, and we will save a new order. So order builder, and let's add the product ID, so dot product ID, and we will build a product ID by using the product ID as we did like earlier with the rest, and we will use the total price, just like total price will be the quantity times product dot get price. So product response dot get, not dot get, dot price, and there you have it, this exact method. And now in our order controller we can just like add this post mapping, so post mapping just like that, response entity placeholder, and we'll just return new response entity dot okay, and we will use our order service gRPC. So let's just change this to gRPC. So let's use the order service dot placeholder, and we will use the order request product ID and order request quantity, just like we did earlier with the rest. So there you have it. We create a really fast internal service communication using gRPC. Now using gRPC. Now we have a few problems with a lot of stuff, and gRPC isn't that simple to start with, but after you will go over those little problems, you will start to understand the real power of gRPC. Now that we understand how services communicated, let's talk about how they handle data. For microservices to be truly independent and fast, we must avoid a shared central database. Instead, we follow the database per service pattern, where each service owns its own data. In some cases, a service might need a data that technically belongs to another service. For example, the other service need user or payment information. If we made a network call to the other service every time, it would create a massive query overload and slow down the entire application. To solve this, we often keep a local copy of the necessary data within the service's own database. This allows each service to be truly independent and high performance, ensuring that a bottleneck in one service does not bring down the rest of the system. After you understand what a data per service means, it doesn't become much more complicated than that. Each service has its own database. Straight on. Now, in our product and other services, we already have, and each and one of them has their own database. Like right here in the YAML file, we have productdb database, in memory h2 database, and right here as well. We also, right here, we have our own database, which is the order.db database. So as you can see, we implement the data per service without even realizing it. Now, data per service has another layer, and it is focused mainly when we need that data frequently. If we have one main database, we will probably fetch it for the product and all of this stuff, but right now we split our database. And we call to our database when we're trying to place an order. Let's go into the order service. Our order service right here. Ignore the arrow for a little, but right now when we are placing an order, we are making a request to the product endpoint. Right, we are using here gRPC just for the example. The other example, in our other service, we are using REST. But actually, if we need a data as frequently as that, we are making all of the calls just like that. So now, with the help of the data per service, we actually need to make a few adjustments. First of all, let's go over and look at our order entity. So right here we have the ID, product ID, quantity, and total price. But you are missing one key ingredient right here, which is the product price. We cannot actually just use the product ID right here, because if the price today is $45. Tomorrow it will become $50. Price can change very quick and very easily. We don't want to bound our product ID to the total price. We also need to keep a record of exactly what they bought at exactly what was the price at the time of the purchase. Maybe in the future we will need it, but right now, because we don't want to make a lot of calls and also we need to preserve the right data, we need to create the order items, which will have the ID, the order ID, the product ID, and product name, and the product price and the quantity, which will be like the order entity with more data to actually create an order. So let's create it real quick. New Java class, and it will be called order item, and let's click enter and let's add our annotation. So first of all, with the entity annotation, and now let's add all of the other needed entities annotations, like all args constructor and no args constructor, and let's add getter, setter, builder for the builder pattern, and that's around the annotation that we are needing. Now we need to define our ID. So right here, quick ID, generative value. We can just remove this, and we have long ID. Now the ID could also be the order ID. We can also just use the order ID like that, order ID as well. They just add the product ID, quantity, and now we need a few more properties. First of all is the product names, string product name, and now we need the price. Now we need the price at the time of the purchase, so double, so let's use double product price, and we will add at purchase at order at the time that we are ordering. Now let's create a little spacing between those. Now when we are replacing the order, we can save the order ID, the product ID, the name, and all of the most important parts. Now we can actually remove the order ID, just use a simple ID, and we can also remove the orders table because we don't actually need it, because we have everything in the order item. But because the total price, we will keep it. We can also add right here the total price of the order, but this is for the specific item of orders, because we don't want to, every time that we are creating it, to go make the call, make the request to the product service and all of this stuff. Now this part of the is remind the principle that we have talked about, that sometimes when we have a database that we need more than once, we create a copy of the database. We create a copy of the tables that we are needed inside our database in the other service. Now this is very similar to it, because we're keeping all of the most important parts right here, which is the product ID, the name, and the product price. We can also create a product right here, a product entity as well, just like that, product, and we can add all of the product stuff in case we ever needed more information about the products. And when we will create new products at the product service, right here we will need to create another to update the product entity that will be right here. Let's just say that we are creating it, so we will have all of the annotation. Let's just take them from here real quick, and we have all of the annotation, and we need just like an ID. So we have the ID, we have generate value. Now we have a private string name and description. We don't actually need. What we do need is private double price. So if we see ourselves that we are doing a lot of calling to the product service, and we can minimize it by creating a copy of the product entity. We can also call it product copy. Let's just change the name even, rename, and we can call it product copy right here, that we could use if we don't want to make a calls every time that we need something from the product service. So this is the main idea behind data per service, which help us makes our database much simpler per each service and make each service independent. Like the product service doesn't even know that there is an other service that is waiting for him. Not like in any like means like REST, the order service makes the request, it asks for the product service, all of the stuff. The product service just shown the API and that's all. Now, this is the beauty of microservices, and also data per service help us improve upon it. So, I'll see you in the next one. Now that we have many microservices, we need a single entry point for our client. This is the API gateway. Think of it as the front door of your system. Instead of the client needed to know all of the address for every single service, you just send her one request to the gateway. The gateway is responsible for routing the request to the right service, handling authentication, and even rate limiting to protect the system from overload. It can also act as a translator, receiving a simple REST request from the web and turning it into fast gRPC calls for our internal services. This way, the client stays simple while our backends stay powerful and decoupled. In microservices architecture, your clients shouldn't need to know the address of every single service. That's where the API gateway comes in. It's a single entry point, as we are already explained to you. So, the API gateway uses to make sure that our application has one entry point and our client doesn't need to know every single service just to make simple operation like ordering something or doing something like that. Let's say a user want a product. To get a specific product, let's take a desk. We are creating a furniture store and the user, the client, wants to show a desk. He needed the product info like name, image, and more, just for the idea. But then you will need to know the exact path for the product service. We can handle it, but wait. What if you just click on it and want to create an order? Then the client would need to know also the order service path, and this is when everything becomes kind of a mess. So this is why we are using the API gateway. The API gateway makes things much simpler for us as we just relax and much simpler for us as we create one service that handles all of the requests and knows how to route them correctly to its service. Now let's create our gateway service. So new project, let's call it gateway service. Just like that, we will use Maven and YAML. Now let's add the gateway dependencies. So gateway, we will add the gateway dependencies, and let's add those dependencies. Hit create, and we will open it in a new Windows. Now we have all of those services right here. This is one of the beautiful things about IntelliJ. Now let's go to the content.xml, and now you can see our dependencies. Like the first of all, we have the Spring starter for the gateway, and we have the ones secure web flags, which is for security that we will talk later on. Now we need to configure our API gateway. First of all, we will give it the port, which will be 8888, and then we will configure it to know exactly how to route to the different services. So right here, src main resources application YAML. Let's add the needed configuration right here. Let's add first of all the port, so server. Let's add the port. This one will be 8888. And right here we'll need to configure the cloud property. So cloud. Now let's start to configure it. First of all, the gateway. So gateway and routes. So route just like that. And now let's add first of all the ID for each route. So the ID will be product service for the first one, so product service, we have an identification for each and one of those. And the second one will be URI, just like that, and the URI is http column local host, and we are on port 8081 with the product service. Now let's just configure like which route we have in this. So we have the slash product endpoint, so predicate, and now let's add new, and it will be path equal to slash products with an S, and this is our main endpoint, like the endpoint that the product service expose. So right now let's create this again, but now just for the order service. So order, it is on port 8080 and it will be the orders, just like so. Now we configure the API gateway. Now the gateway itself has zero business logic. It just looks at the path and forwards the request. All of the requests for slash products go into port 8081, and for orders it will go to port 8080. So this is actually like what we needed to do. This is like everything, and let's show you just an example to show you exactly how does this work with Postman. So we will open Postman, we'll make a request to localhost port 8088, and we will go to slash product slash ID, and we will retrieve the ID with 1. We'll first of all create the first one with ID of 1, but then we will return it, and then you will see that it will give us the result from right here. So let's go to the product service. Let's just add mock because we are using in-memory database, so we don't actually have any ID. So let's create the endpoint for creating IDs, for creating products super fast. So post mapping, real quick we'll do it, just hit enter, look, nice. Now, yes, it's quite valid. We will create first of all the product, and it will have the ID of 1, and then we'll try to retrieve it from the get right here, and then in the same session we will use the order service. We will use the controller from the order service right here. Let's open it up just to give a look, and we will just place the order. Just use the placeholder just like that. We will use the simple order service because we just want to show you, and we don't want to go into the complication of gRPC. So real fast, let's do it. So let's open Postman. So this is how we are using the API gateway. It's one of the most important thing when creating microservice application. It's super important to create this and to know it, to make things on the front end and on the back end better, more secure, and easier for us as developer to develop our application faster. Now we also have another problem with API gateway, and in microservices as a whole. We have a problem with security. We don't exactly know how can we make security, like where should we put like the security rule configuration, all of this stuff. So next we'll talk about how to make our gateway secure, and then we'll talk about authentication and in our microservices. So this is for now. So right here, let's add a new project, Spring Boot, and this will be the user service. We will pick Maven, YAML for the configuration, and next. Now we need to add all of our dependencies. So let's start with Spring Web. So Spring Web, and the next will be Spring Data, Spring Security. So Spring Data JPA, and Spring Security. We'll pick this one. And the next one will be H2 database, in-memory database. We will use Lombok, and JGWT we will add later on. So create, we'll create it in a new window right here. Now we have all of those beautiful services. This is one of the things that I love about IntelliJ. You can develop really easily microservice application yourself even. So this is it. Let's add the JWT dependencies. So right under all of the dependencies right here, we'll add a few new dependencies. So it will be, let's use dependency, and the artifact ID for the first one will be JJWT, and it will be for the API, and it will be from here. And now you can just like copy it out and create this new, but let's do it real quick. Dependency, let's add the JJWT implementation, just that, and next one, yes, I need to correct the version. And lastly, we need to add finally for JWT the Jackson. So just that, and now let's load Maven again, and we have all of the dependency that we are needing. So right now let's create the user entity real quick. So see Java right here, we need to create the user entity for the user. So user, and now let's do it really quick. So first of all, entity. Now let's add all of the rest of the annotation. So the next annotation will be the getter, setter, all of those stuff. So getter, setter, all args constructor, no args constructor, and let's also builder. So we could use the builder pattern. Now you already know every entity needs an ID. So ID and generate value. So this one, let's import it. And now private long ID. Now let's add the column, which is username, password, and role real quick. So let's just change this one we don't need. So let's just change this one to name, and private string, this one will be password. And instead of name, let's use username. And finally, we will add the role. So string role, just that. Now let's create a few DTOs really quick. Java class records, and we will call them login request and user request. So login request, super fast, it will be a string username, so string username, and password, just that. New Java class, this one will be also record, and each one will be for the user response. Super fast, it will return the string of username, so string username, and the role. We don't return the password to the user, security reason. So those are the DTOs, and let's create also the user repository. So Java class face user repository, extend JPA repository, not CRUD repository, JPA repository, and let's add the repository annotation. Just nice. Now we have all of the setup for the database and the request. So now let's add all of the security stuff. First of all, let's add the JWT util. So right here, new Java class, and this one will be JWT util class. It of course will be a service, so let's use the service annotation, this annotation, yes, and let's add require. We don't actually need to have a constructor because we will use value annotation for the secrets and the expression. So two field will be private string secret, string for the secret, so secret, and we need another private long number for the exploration, so long expiration. Nice. Now let's add the value annotation for each one of those to get a value from the configuration value right here, value, and it will be in a JWT.secret, right? And this one will be a value in a JWT, you can already guess, JWT.expiration, just that. Nice and easy. Now let's create a few important methods. The first one will be signing a key, so it will be a private method for internal use. So private, it will return a key, and it will call signing for signing the key. So let's create this method. Nice. Now we will return simple keys dot key for, and we will use the secret. We will get the bytes, and we will use standard characters UTF-8. And It will allow a specific UTF-8 explicitly. Default platform for encoding is not generated to be consistent. So this is the method for creating our sign. Okay, now let's create our next method for generating the token, validating the token, and get the claims from the token. So real quick, public string generate token. Let's get the username. So it will be just like string of username and also string of role. So super quick, let's just do this. So let's return the JWT builder, and let's build the token. So set subject, and the subject will be the username. Now claims, so claims, let's get the role of the user, and we will add role is role that we have right here, not like that, yes. Now let's set issued at, so we will set issued at, and it will be a new date, and set expiration for this token, it will be a new date. And let's go to system.current time in milliseconds and plus the expiration time. So expiration, and now let's sign it with, let's use the sign key that we created and compact, and now we have token right here. This is our generated token. Now to our next method to validate the token. So public boolean validate token, and we will get the token. And now we will have this in try catch block. So try catch, we have this try, let's use try, and we will go and use JWTs dot parse builder, and now set sign key and to sign key for the method, and we will build it. And now use the build, and after the build we will use the parse claim JWT to get the claim. So parse claim JWT, and we will put the token right here, and if all of this process will go, we will return true, and if we catch an exception, we'll return false. Great. So now for our final method will be for getting the claims. So public claims, we will call it get claims. So get claims, and we will have the token. So we will return JWTs dot parse builder, like we did earlier. Parse builder. So let's do it quicker. So parse builder, let's use the set signing key to the signing key method. Let's use the build, and now parse claim, and we will get the body. So this is all of the method that we need in our JWT utils class. So right now let's go and configure a few things in our YAML file. We will configure the JWT secrets and expiration. We will configure the data source that we didn't set yet. So right here, YAML, and let's set the port. So server port will be on port 8082, and let's add the data source. So right here, data source, and the data source URL will be jdbc now h2.mim user db. Just that. Now let's configure our JWT secret. So right here, JWT secret, and we have the secret, and we also have the expiration. So the expiration will be for a whole day, which will be 46, and now 1 2 3 4 5, because this is in milliseconds. This is the expiration for 24 hours. And for the secret, and now to create the secrets, let's go right here to the terminal and write this command: open SSL rand for random, and we'll use base 64 and 32 for the bytes, and this is our secret. We can also make it long secrets by changing the number from 32 to 64, but let's use the 32 for now. So copy it and paste it right here. So we also have the secret. So we configure everything we needed, and now let's create our controller for the authentication. So right here, user new control, and we'll call it auth controller. just like that, and let's just make all of the annotations super fast. So first of all, the REST controller, the second one is request mapping, request mapping, and it will be mapped to /auth, of course, and require a constructor. Nice. So let's add all of the needed fields. So first one is private final user repository. Next one will be the password encoder, and lastly will be the private final JWT service. So JWT utils service. So just that, and now let's create the login request. So it will be post, and we will map it to /login. Now it will be public response entity. It will be a map of string and string. So string and string, let's import it, and it will be called just login, very simple. Now let's use our login request DTO. So in the request body we are expecting, in the request body we expect a login request, and let's just call it request. Nice. Now let's implement the method. So user, we call it user, equal to repository find by username. So user repository dot find by username. We can create this method in the repository real quick. So repository right here, optional filter find by username. Yes. Back to our authentication controller. Right here we'll add the username, the request dot username, and if we don't have it we will use the or else throw, and we will throw a new error. So let's use lambda function, and we will throw new runtime response status exception, new response status exception, and we will add http. So http status, and it will be unauthorized. Great. Now if password encoder match, the password from the request will not match the user password. If this return false, we will throw new status of forbidden, of unauthorized as well, not forbidden, so unauthorized. And if the password does match, which means this if statement will not evaluate to true and will not result in throwing this unauthorized error, we will return response entity of OK, and in the body we will return a map of token. So right here we'll add the token, and the token will be JWT util. We use JWT utils generate token, and we will add the user dot get username, and we will get the role as well. So this is our login method. Right now let's create the user controller to get the user by the username. We need those for our API gateway. So really quick, user controller, all of the annotation real quick. So REST controller, request mapping to /users or /users, and require our constructor. Yes. Now let's add the repository fields. So real quick, private final user repository. So now let's add the get by username endpoint. So get mapping, so mapping, and this one will be /username. We'll use username, just that. And now we will return a user response. So public user response find user by username, and we have the username in the path variable, and real quick return user repository. So user repository dot find by username, we will add the username right here, and we will map the user to a user response on new user response, and we will add the username and the role. So user dot get username, and we also add the role. So user dot get role. And if we don't have a username, and if find by username does not find a username, we will throw or else throw. We will throw new exception. So it will be new response status exception. So new response status exception, and this exception will be HTTP not found, status of not found. Nice. Now finally, to our user service, we will add the configuration for our security. So here, new Java class, this will be called security config. Just that. Let's add the configuration and the enable web security. Exactly that. And now let's add two bins. The first one will be for the password encoder. Nice. And the second bin will be for public security filter chain. So security filter chain. So security filter chain, and we call it filter chain, and we will have the HTTP and it will throw an exception. So let's return http.csrf and we will disable it. So crf, and let's go to chef.disable. So disable, you do not want to use it. You could also use the method reference here. Nice. Next, authorization, authorize HTTP request, and we will authorize for all of so auth.anyQuest.permit all. Next session, let's add the session manager, session management. We will use session management, SM for short, and we will use sm.session creation policy. So session creation policy, and the session creation policy will be stateless. So session creation policy will be stateless. And finally, we will build it. So those are all of the configuration that we are needing in our user service. So now let's go to the gateway and add all of the necessary dependencies and configure our security. So gateway pom.xml, let's add two new dependencies. So the dependencies, this will be the security starter and starter for Redis reactive. So Spring starter security, nice. And the next one will be, and this one will be for Spring Redis data reactive. The reactive Redis client is required by the Spring Cloud Gateway built-in request limit filter. So we will use it. Now wait, now we sync it up with Maven, and now we will need to add the dependencies of the Jackson for the JWT right here, user service. Let's go to the pom.xml file and let us grab those three dependencies, copy those, and just add those right under here. Load Maven, and this is for our dependencies. Now let's create our JWT utils. So right here, main Java new, and this will be also the JWT utils. So let's go over to faster because those are similar methods. So JWT util, let's use the service annotation. So service, and let's start with the private string secret, and let's grab it from our configuration file using the value annotation. So value, and this will be jwt.secret, and we will create a secret when we will configure our YAML configuration files. So now most of the methods are really similar, so we can just copy and change the one that we needed. So we have four main methods: the sign key, validate token, get claims, and extract token. So right here in our JWT, we have the sign key, the validate token, and the get claims method. So we could just copy all of those instead of creating those again. So copy those, go to the gateway service right here, let's upload those. Now let's remove the one that we didn't need. We need get claims, validate, but we don't need to generate token. And now we need to add a new function, a new method to extract the token from the request. So right here, it will be public string and we'll call extract token. So extract token, and we will extract the token from the request. So it will be server HTTP request. So we'll call it request. We will import it, and right here, so string, we'll call it authorization. So to get the authorization header. So authorization, yes, quest.getter, and we'll get the header for the authorization. We can use get first, and we can use also HTTP headers instead of writing this manually. So HTTP headers, and we can use the authorization like we did with the status type that we did earlier. Now let's add to check out if we do have an authorization header. So if we don't have authorization, if it's evaluated to null, and this we don't have it, and the authorization start with bear. If it's different from null and it start with bear, we will return the token with the substring of 7 because this is the bear. The first 7 letter is the bear. The next one, and if we don't have it, we will just return null. Now let's create our security configuration for the gateway. So we need those security configuration because the gateway is the first one to come, so we need to make those configuration are very important. So right here, new Java class, and this one will be for security config. Nice. And let's add the annotation of configuration and enable security. Let's add the bin for the filter chain. So a new bin, it will be public for security web filter chain. So that, and we will call it filter chain, and we will get the HTTP, the server HTTP security, and let's import this project, this class, and let's return HTTP. We need to return HTTP dot, and now let's add all of our configuration. So CRF, and as we did earlier, we will disable it. So CSRF, go to the method, and we will disable it. So disable. We could also use the method reference for it. Nice. Now HTTP basic for the security, we'll use a method reference like we did earlier. So server HTTP security, and we will use HTTP basic spec, and we will disable it. So HTTP basic spec, and we will disable it. Next, we will disable the form login that Spring create automatically. So form login, let's disable it. So Spring HTTP security form login spec, and we will disable it as well because we have our own login. And finally, authorization exchange. So authorization exchange, and now let's create the method. So it will be exchanges. So exchanges, and we'll go to the lambda, and we'll call exchanges dot path matchers. So path matchers, and it will everything that will match the path of auth, we will allow it. So auth dot permit all, and any other exchange, so any exchange we will permit as well, so permit all. So this is it, and now let's build it. So those are our configuration. We will disable basic web security, CSRF, the form login that creates automatically for Spring Boot, and we will find exchanges. So now we need to create the record for the user response. So we can just copy right here, we can just copy the record for the user response because we need it. So right here, copy and paste it. Okay, now we have it. Nice. And now the authorization filter is where all of the pieces is connected. It extracts and validates the JWT, fetching the contextual user record from the user service using web client, and enriches the forward request with the X user ID and X user role headers. So if the token is missing or invalid, the filter short circuits with 401 before the request ever reaches a route. So let's create the authorization filter. So right here, new Java class, and this one will be the authentication filter. So authentication, and it will be authentication filter. That let's add the component, not configuration, component annotation, and we will need to extend. So extend abstract authentication process filter. We will need to extend the abstract gateway filter factory, and it's a generic type, and it will be a generic of authentication filter config. So authentication filter dot config. So authentication filter dot config. We will add this in a moment. So right under here, we will add a new class, a new static class inside here. So public class config, nice, and we will make it a static class. So static right here in the end. So let's add all of our parameters. So private final JWT utils, and the web client. So private final web client. Now let's add right here the require a constructor, so we arg constructor. We don't have. So let's add lombok, so we have those annotation, because I don't feel like creating a constructor. So right here, dependency lombok from lombok, and we need to add a plugin for lombok. So plugin artifact ID will be lom. So let's add lombok right here. Great. Now we can save up. So require our constructor, and now let's create our authentication. So now let's create our filter. So we need to override a method that we have right here. So override, okay. So we need to override this apply method. So it will be config. It will be a capital. So config. It will be config. Now we will return this function, right? So it will take exchange and chain. And let's explore it. So first of all, we need to get the token. So string token, and we will go to the JWT util. So JWT util, we will extract the token from the exchange, and we will get a request. Now we have the token. Now, if the token is null or the token isn't valid, so if the token is null or JWT validated token, if it's returned true, so it will evaluate it to false, and if it returns false, it will be true. So if the token is null or invalid, we will exchange get response, and we will set the HTTP code, so status code, and we will set it to unauthorized. So HTTP status, and it will be unauthorized, and we will return exchange.getResponse.set complete. So we will finish right here if we don't have a token. But if we do have a token, we will create the claims, we will get the claims, and we will return this. So return user. So let's return a web client get, and we'll use the get, and the URI will be, so URI users slash name, so slash user. So let's add the URI, and this one will be for users and for the user name. And let's add right here from the claims, we will get the subject, which is the username. Now we will retrieve, so retrieve, and now so body to mono, and we will use the user response class. Not that, we will use the user response class, user response dot class. Yes, and let's continue, and we will filter map. So flat map, real quick, we will have the user, so user response, go to this method. Yes, a lot of method inside of method, I know. Lambda, so server HTTP request, so server HTTP request, it will be a request, and we will get the request muted, and then let's continue. And now let's go to the headers. We will pass the request forward from right here, so let's just create it. So right here we'll have x dash user dash ID. Now we will set the ID that we will pass on, so user, it will be user response dot username. And now we also need to set another header, which is the roles. So right here, another header. This one will be the x user dash role, and let's set the role to the user response dot role, just like that. And we will build it, and semicolon, and now we will return the filter chain. So return chain the filter chain, and we will execute. From the exchange, we'll take the mute, and we build the request. So build the request with the request right here. We will pass it forward. Nice. A semicolon right here, and a semicolon right here as well, and a semicolon right here as well. So a quick fix for this red line will be to go right here. Just again, we use IntelliJ, so it's very simple. It will add the gateway filter, it will save it, and then it will return it, and now we will, yes, and now not weird arrows. Great, nice. So we finished with our authentication filter. So now we need to configure a few things. Now we need to configure the rate limits. Oh, new rate limiter. So we need for the rate limiter, and we will add the configuration. So config right here, of course, the configuration annotation, everything we know. So let's do it real quick. Now we will add a new bin. So bin right here, and it will be key resolver. So public key resolver user key resolver that we will return exchange dot mono just get request. We will get the header and we will get the first header, so not the get query param. We will get the headers. We will get the first header for the user IDs, so get first for user ID, so x user dash ID, and we will, after we have the user ID, we will default if empty, and if it will be empty, so default if empty, it will be unanimous. So we can just give it a null value or unanimous, so unanimous. And that's our configuration. Maybe we could use a method reference. Nice, looking good. So finally, after all of this, let's add all of our configuration. So right here, we need to add a few configuration to the amplify. The secrets, of course, but before the secrets, we need to add a few more things. So first of all, the data ready. So right here, Spring, we'll need to add the data. Right here, we will have redis, and it will have two main stuff. So first one is a host, and the next one will be the port, not post port. The port will be on 6379, and the host will be local host, as we are developing it locally, so local host. And this is for the redis configuration. Now let's add a few configuration to the other service, because we do need filters for the other service, like a request limiter, rate limiting, and all of that important stuff. So let's add a new filter. So let's add all of the filters. So real quick, then we'll add names. So name will be a authentication filter. So this will be authentication filter, and we'll have another one, name retry. So we'll have two, so retry. Nice. Now let's add the arguments. So args. So we'll have three options for retry. So retries, we will have 3 attempts for retry. For the methods of get and post that we have right there, and we have back off for, so we'll have back off, so for a little bit of waiting time. So the back off will be for 50 milliseconds, and the maximum backup will be for 500 milliseconds. So first back off will be for 50 milliseconds, and the max back off will be for 500 milliseconds, half a second. Now factor for 2. I will explain all of it in a bit, just bear with me. We'll go over them one by one, but now let's just write the code. Name, now we'll add the rate limiting. So request rate limiter, and arguments, so args. Now we have 3 args. Now for the argument, we'll have 3 arguments. The redis rate limiter dot replenish rate will be 10. We also have very similar to that, so time. Let's remove this one. So the next one will be burst capacity. So burst capacity. This one will set to 20. I will explain all of it in a bit. Just bear with me. Key resolver. Now, just a second. I will explain all of it. Promise. And now we'll have it user key resolver. Just like that. And now we will need to add a new route for the users. So let's add it up there. A new ID. The ID will be auth service, and it will be URI will be HTTP 8082. So HTTP the dash local host, and it will be on a port 8082, and we'll have the precedence of path. So precedence of path will have the, so let's configure the path we have the auth path right there. Yes, we have it right here. Nice. So there we also add the services. So now before we'll add the JWT secrets, let's just go over and explain the filter that we add. So, application filter is a custom filter that its job is to make sure that the user sends the request is authorized to get to the resource. So it checks with our authentication filter that we just created. Now the next one is for the retries, and this one is for improving our stability of the system. If the request fail for a temporary issue with the internet maybe, the gateway try to send it again automatically by the next settings. So we will retries 3 times and the attempts will only be made for the get and post. Now the backoff is the strategy for waiting between each attempt. We will start with 50 milliseconds and the time will go larger by 2 each time, which means we start at 50 and 100, 200, etc. Now the maximal wait time that we send the max backoff will be for half a second or 500 milliseconds if you prefer. Now lastly we have the request rate limiter. Now the first one is the rate limiter to send to the other service. So let's say something went wrong and we have we try, and so the request rate limiter is stopping from the user to give too many requests, and by doing that will slow out our system and will make a lot of problems for us. So this one is for the amount of time, the maximum attempt to reach to our resources. Let's say sends 1 request, 2 requests, 3 requests. Like the maximum in 1 second will be 10 in every single second. Now we have the burst capacity, which the burst capacity is for a certain case. When a user did not use the product for several hours or several times, then it will allow up to 20 at the first attempt, but after that it will go down to 10 as well. Now the key resolver is the most important part. He decide who is the user that we are counting those limit for. So we will tell the system that we are using this user. So that's for it. Now let's create our secret key for JWT. So now let's add our JWT secrets. JWT secret, and right here we will create a secret with OpenSSL like we did earlier. Open SSL rand. We'll use the base 64 and we will create 32. So this is the secret. We'll short just that. Nice. So those are the configuration, and lastly I'll show you how we are using all of the headers that we are getting. So let's go to the order control, order service right here. Let's go to the controllers, so controller, and now we have a few more arguments to take. So first of all, we expect to take 2 arguments for the header. The first one is the ID and the second one is the user role. So real quick, request header, so request header, we will have the request header and we will search for this specific header of x user dash role. It will be string for the role, and let's also take the ID. So request header, we will have the x user ID, which is the username. So string username, it's more suitable. We can also add the user ID, although it's the username. So this is it. And now when we want to create an order, we can create an order with the user ID, because we need to know if we encounter any problem and let's say the order didn't pass and we need to try again, we also need to know for each user, maybe he canceled it, maybe the user canceled the order, so we need to know those data. So we can like add another method that will be called like create order, and in this method we will take also the ID of the user, so it will be string ID, string user ID, and we will also take the order itself, so the request. No. Yes, and in this method we need the user ID, and maybe we'll need the user role, but most of the time we don't actually need it. So from the gateway we get those two parameters in the header. So this is around it for gateway security. I know it was a long lesson, but worthwhile. The security is one of the most, if not the most important parts of our system. And as a backend developer, we must make the best security that we can. So we learn how to create real good security in the gateway. And in the next lesson, and so that's it. And in the next lesson, in the next module, we'll talk about the resilience pattern, which will be quite a long run, but a very important one. So I'll see you there. In a microservice system, service will eventually fail or become slow. If one service starts failing and we keep sending it requests, it can cause a domino effect and take down the entire system. That's why we use the resilient pattern. The first and most important one is the circle breaker. Think of it like the electric fuse in your house. If a service starts failing repeatedly, the circuit breaker tips and stop all calls to that service for a short time. This gives the failing service time to recover and prevent other services from wasting resources waiting for response that won't come. The second pattern is the blockade. It's named after the compartment in a ship. If one part of the ship flowed, the blockade prevents the water from spreading to the rest of the ship. In microservices, we do the same by isolating resources. For example, we can limit the number of connections to the search service so that even if it slows or overwhelms, it won't use up all of the memory or CPU needed by the checkout service. To wrap this up, resilience patterns are what make a system cloud native. The circuit breaker stops the fire from spreading, and the blockade ensures that one heavy or broken service does not sink the entire application. This is how big system stays online even when things go wrong. So in this lesson, we will talk about the resilient and how to implement it in Spring Boot. We will use the resilient for J dependencies that gives you 5 independent tools to break all of those problems that we have talked about earlier. So we have the circuit breaker that stops humming a failure service. Retry handle transfer hiccup, time limiter prevent independent waits, rate limiter protect a dependency from being overwhelmed. Blockade isolated thread pools so one slow path cannot starve the rest. We will build all of those fives, but before we can dive straight into code, we need to add all of those dependencies to test Spring Boot exactly from which library to take it. So to in the other service right here, we will go to the pom.xml file and we will add 2 new dependencies. So right here, we will add the resilient 4J dependencies. Resilience, so resilience for J dependencies. Resilience Spring Boot. So this is the dependency that we are looking for. So hit enter, and it will pull out the latest version. Now let's add AO. Now let's add the Spring Boot AOP starter. So just add it. Now we are using the Spring AOP, which AOP is stand for Aspect-Oriented Programming. AOP allows you to add a behavior which is logic to existing code without modifying the code itself. We will dive right into it and explore it in more detail later in this lesson. So this is AOP. So now we need to load those dependencies and add a few configuration before we can go into the actual code. So let's load it. Everything is working. Go right here, src, Java, and let's go to the REST configuration. And we will need to add 2 new configurations. So the first one, bin, and now we need an inventory client. So not order client, inventory client, and let's just change it a little. It will go to http:// inventory service. So this is the inventory service like we did earlier with the product service. And we actually can change this product service to use the product service instead of a fixed URL, because we can just use it. And now we'll need to add the task scheduler bin. So new bin of task scheduler. So executor service, we'll call it task executor, and right in here we'll return executor new schedule thread pools of, let's set it up, instead of 10 we'll set it up to 4, which is the thread pool that we'll use. And we need to have one more thing, which is anno. Now this scheduler have two main things. One of all is the timeouts management. One of the most important tools in resilience is the timeouts. If a service doesn't answer in 2 seconds, we want to cut a connection to not stuck the user. So the service executors, the scheduled executor service is run from behind, giving the time and give the order to stop the method if the time is over. Now let's add the circuit breakers logic into our code so we could better manage and resilience our application. So right here, let's go to the order service. Right here, when we're making the call and creating the order, just that. Now let's extract this method to a new method called getPro right here, and we could extract it, as you can see, to a method in IntelliJ. So we can click here, or we can use the shortcut. On Mac it's Option, Command, and M, and we can extract it to a method, and we will call it getProduct. Not response, just get product, and we'll change it here as well. It would look better just get product, and let's change it right here as well, get product. Great, so we extracted it into this new method. Now let's add the circuit breaker logic. So the circuit breaker sits between your services and any downstream dependency. When failure occurs a threshold, it's open the circuits and immediately return a fallback without waiting for the downstream service to time out. This protects your threads pool and gives you the failing service time to recover. So this is what we have talked about AOP. AOP is when we add our logic without interfering with our code. This is the logic, alright? We have the circuit breaker, which adds all of the logic. So just a second to show you how it would look in code. So circuit breaker, and we first need the name, and the name will be not capitalized, product service, which is for the service. And now we will add the fallback method. Fallback method, product back. Now let's add this method real quick. Private product response, product fallback. We will get the ID and the exception, thrownable, and we will return a new product response. And in right here we'll add the ID. We will add an label. Right here we need to add a unavailable, and we'll add here unavailable, and in the price we'll add 0.0. So this is our fallback method. In case that this method won't return anything, we will return this. We will return that. We add the circuit breaker annotation, and we will add the fallback method in case that we have any problem with the product service. We add this fallback method. Let's say the product doesn't answer, the product service calls a massive amount of requests. So the fallback method is this method right here. Now the amazing part is that we didn't need to add if statement, a lot of boilerplate boring code. Let's say right here, what we usually do is take the product, let's save it as a product. So product response, we'll save it as a product response, we'll get it, maybe product rest, and now we will check right here if product is null, and then we will return that. Nice. But instead of adding all of this logic and all of this stuff, we just use this method, and in case that it won't work, the fallback method is that one. And we keep our code incredibly clean. So this is the circuit breakers, and this is how we simply add it to our code. Now the circuit breaker has three states. Close mean calls pass through normally and failure are counted. Open mean calls are rejected immediately and fallback runs without awaiting. And 3 half open, which means a small number of probe calls go through. In super short, so you have three main states of the circuit breaker: open, close, and half open. We have a little problem, a little situation, and the circuit is half open, and a few requests goes through our get product response, and if everything is working, the circuit is closed. So this is it. Now we need to add a few different configuration to our circuits breaker. So let's go to our YAML file for the configuration. We already know it pretty well. And now we need to add a few configuration right here. So and 4J. And now let's add our configuration. So for the circuit breaker, so circuit breaker, let's add a few configurations. So we will add the instance. So instances, we have the product service that we add all of the logic to. So the service, and now we will add a few different configurations. So the first of all is the sliding window size. So sliding size, and we'll set it to 10. So the sliding window size is the windows of call that the breaker will work from. It will take the last 10 calls, the last 10 requests that we have performed with the product service. Let's say we have 100 requests. It won't take all of those 100 requests. It will take only the last 10. And by doing that, the windows size is very small and can allows us to change things in real time without being overwhelmed by all of the calls. So the circuit breaker gets only the 10 requests. The last 10 requests that happens and decide what to do with that knowledge. Now we'll add a few rules that tells them exactly what to decide if something fails. So the next one will be for how much failure rate we need for the circuit breaker to open. So right here it's a dash rate dash. Now this is the percentage of call that wasn't successful. So this is the settings that tells how many fail calls we need to open the circuit breaker. So in percentage we have 50, which is 50%. If you have more than 50% of failing calls, the circuit breaker will open. And now finally we need to add the final configuration. So let's add, we call it perimeter number of calls in half open state. So and state, and we'll set that to 3. So the half open state, we already know, is a trial phase where the system will allow a limited number of test calls. In these times we set it to 3 to pass through. So if they succeed, the circuit breaker closed, and if they are failed, the circuit breaker opens again. So this is in the phase when the circuit breaker thinks that we can go to normal, and it just sends 3 requests and 3 calls to see what is the status. If they pass, great, we can close the circuit breaker. If they not, there we have a problem and we need to close it again. We need to open it again. Now to our next things is the retries. Retry handle transit failure, the kind that self-correct after a brief delay, like a network hiccup or a downstream pod. So unlike the circuit breaker, retry does not track a failure rate. It simply re-executes the calls with configuration backup. So we will add right in the other service, we will add the retry above the circuit breaker annotation. So right here, we'll add our retry. So retry annotation, and we need to have also the product service and also the fallback method. So the name will be product service, and the fallback method, it will be the product fallback. So as we did earlier. And now let's add the configurations for the retry. So right here, retry. So the instance set is also the product service, just like that. Now we'll add the maxed attempt for the retry. So max attempts with an S. We will set it to 3 maxed attempts, and we will add wait duration between each and one of them. So wait duration, and we will set it to 500 milliseconds, which is half a second between each and every retry call. And lastly, enable exponential backoff, and we'll set it to true. The exponential backoff, which means that every time we wait, like, I will give you a simple example. We wait 1 second, and in the next time we wait 2 seconds, and then we wait 4 seconds and 8 seconds, and so on and so forth. So this is the exponential backoff. And now we'll have max exponential backoff multiplier, which is the amount of multiplication that you will just take the backoff. Let's say each time we want it to double the time of waiting that you did in the previous time. So let's say half a second, 1 second, and 2 seconds. So let's add this. So exponential backoff multiplier. So multi, and we will set it to 2, which means each time it will multiply the wait duration by 2, which means 500 milliseconds, 1000 milliseconds, 2000 milliseconds, and then we hit the max attempt. So let's add the retry exception, which means which exception we does retry for, and then we'll add the exception that we are not retrying for. Let's say for 500 internal level server we will do make a retry, but for a 401 unauthorized we will not make the retry. So let's just make the retry exceptions, and let's add. So the first one will be java.io from the IO package, and it will be IO exception. And now we'll add the Spring Boot, the status exception. So Spring Boot dot Spring Framework dot web dot client dot resource access exception. So exception. And now let's add the exception that if they occurred, we need just ignore them. So ignore exceptions, and we will add org dot spring framework dot web dot client dot http client error exception. We will ignore all of the exceptions that are just simple exception, as we discussed earlier, like 400, 401, 404, all of those exceptions. We'll add the configuration block, and now the block definition came from shipping and from the shipping world, when each and every compartment in a ship is built with a blockhead. So if one compartment was damaged, and let's say you have a hole in one compartment and all of the water is going in it, the other compartment won't take the damage. So the blockhead limits the number of current calls to a dependency. It will take our But with blockade, that dependency gets a country limit, and the rest of your services stay very responsive. So we have two implementation, and we will use the main one for it. So Resilient4j provide two implementation. The sum for blockade limit counters calls with config with counting 7, simple and low overhead. Threads pools blockade run calls in a detached thread pool. Strong isolation and high resources cost. For most synchronous REST calls, use the semaphore blockade. Let's implement it. So right here in the other service, we are jumping around between other service and YAML, but it's very similar to what we did so far. But we have, in all of those, we have only two arguments stuff in all of those annotations. Now in this annotation, it's a little bit refreshing. We add another annotation. So let's use the blockheads. Blockhead, and right here we'll add, of course, name real quick, product service. Yes, I'm tired from that too. Product service, and we'll add right here the fallback method, which is product. Now this will be a new one for specifically for the blockheads. Blockhead fallback. So fallback, it's a new one. Now we have another property that we need to add here, and this is the type of the blockhead that we use. So we have a few different types. Blockhead.types and we have the thread pool, which is create a new isolation of thread pool and all that stuff, but we will use the semaphore one, which I could explain you as very simple, just like an headlight traffic. It's an headlight traffic method. It just count how many requests running on the existing threads. If you came to the maximum capacity, it just stops the next request. This is the most recommended method in Spring Boot because it's really easy and really good for the performance. So now we need to add the blockade configuration. It's just two simple configuration. It's one for the most current calls, so how many threads we have in the product service at one time. Also the max wait duration, like how many times, what is the duration to wait before it. So we will use reject immediately. So let's do that, but before that we need to add our new fallback method. So real quick, private, and it will be a product response. It could also be like this type, so we can just, let's use that because we are also use the time limiter. So we need us to change the name to fallback, and we add right here block, and now we'll return the new response. We will just change the response a little bit. Busy, try again shortly. So busy, try again short. This is like the kind of exception that you usually see on your computer when you're just chatting, let's say, with Claude. Claude has a massive overload, a lot of users use it at one time. So it's failed, just for you, let's say, it fails and it's returned to you. We are experiencing a massive cause and are not able to answer you right now. Please try again shortly. So then you came up a few minutes later and everything working because the overload, the Claude experience was gone down. Now we also need to take not the thrownable, we need to take a new kind of exception, which is the blockhead full exception. The blockhead full exception, we call it exception because it's a new exception type. So just like that, and we can actually move it. We don't must have it for the simplicity of the code. So remove that and this as well, and we can just. So now let's add the configuration. So right here we will add the blockhead configuration. So let's add the blockhead configurations block head, like earlier, instances. So let's add the blockhead configuration. So blockhead instances service, and now the configuration it's max. So for max concurrent call, which is the most threads, so the most amount of threads that we can give to this resource, max concurrent from concurrency calls, and we will set it to 4, so we limit it to 4 threads, and we'll have max wait the duration time, kind of the timeouts, and we'll add 0 millisecond, which means a wait and just reject it immediately. So 0 wait give instant rejection and predictable latency, and no threads sit blocks waiting for the permit. So no threads waiting for another call or another stuff. We just cancel immediately, which means you have a call, all of the cells are taken. So what you need to do is just like kick it out and try again shortly. Oh, this is it. We have the blockhead, rate limiter, time limiter, retry, and circuit breaker. We implemented like big boys. So we finished this course. It was a pleasure for me to help you along this journey. If you have anything that you think can be used of improvements, I would love to hear it down in the comments. I also love you to tell friends and family about this course and local businesses that you know that really try to grow big and become better in today's online present and needs a fresh brand new website that help establish their brand. I would love you to tell them about the Polaris Studio. And this is for today's course, and I will see you in the next one.